Hello everyone. So back again to solve another initial value problem. Third order differential equation. Very similar to the previous video example. So we have constant coefficients. We know that we have solutions of the form e to the RT. Notice I already found the derivative, so less writing. When we plug these in, the e to the RT's cancel out, and we are left with an equation with just r's in it, and we call it the characteristic equation. So I'm going to write that here, and we need to solve that. So r cubed plus 7r squared plus 11r plus 5 being equal to 0. Now this is where it's a little tricky, or maybe not tricky, but you do have to do some thinking and synthetic division to figure this out, or long division if you want. But synthetic division is a little easier to organize. And it's really come down to guessing what possible numbers would make the left side equal the right side. So one easy one would be 1. 1, if r is 1, you would have 1 plus 7, which is 8, plus 11 is 19, plus clearly is not going to equal 0. So next easy one that I would say is negative 1, negative 1. Plugging it in, negative 1. Plug that into r squared, you get plus 7, which is 6. Minus 11, which is negative 5, plus 5 does in fact equal 0. So we know negative 1 will actually satisfy that. So we can use synthetic division, where we write the number that works and then the coefficients of the polynomial there. And this mimics division. It's basically the process of division, but it takes out all the kind of grunt work of it. You add the 1, multiply negative 1 times the result there. We get negative 1. Add 7 minus 1 gives us 6. Negative 1 times that 6 is negative 6. Summing that up, you get 5. Then multiplying negative 1 times 5, you get negative 5. Adding that up, you get 0. And in synthetic division, these coefficients, the bottom, these are the coefficients of the r terms. So what we did was we know that r minus 1 is going to be a factor. So we essentially can write this as r minus 1 times another polynomial, which is going to be a second degree polynomial, and this will essentially go with the r squared, this will go with the r, and this is just the constant term. So we know this is going to be r squared plus 6r plus 5 being equal to 0. And, oh, I'm sorry, I put r minus 1. That should be r plus 1, because negative 1 is the result that works. So now we factor the r squared plus 6r plus 5. We can break that down as r plus 5 times r plus 1 being equal to 0. And what we end up with here is r equals negative 1 and r equals negative 5 are solutions, where negative 1 has a multiplicity of 2. So what this means is, well, we know solutions of the form e to the RT now. We have two r's, but one has a multiplicity of 2. So we have to create two solutions, two independent solutions to satisfy this differential equation. One of them is going to be e to the negative t. The other, or another one with using -1, is going to be a multiple of t times e to the negative t. And then our third independent solution is going to be e to the negative 5t. And now we can find our general solution, or write our general solution, which is y of t being equal to c1 times e to the negative t plus c2 times t e to the negative t plus c3 times e to the negative 5t. And then we need to solve this initial value problem, so we need to use these initial values to help us find what our constants are. So we need to know the derivative. So the derivative of this is going to be negative c1 e to the negative t using the chain rule. We will need to use the product rule for this expression, so taking the derivative of e to the negative t first, I will have negative c2 times t e to the negative t plus, taking the derivative of t, we'll have c2 times e to the negative t, and then minus 5 e to the negative, 5c3 e to the negative 5t. And then lastly, we need the second derivative, which is using the chain rule, going to be c1 e to the negative t. Once again, the product rule is needed here. So taking the derivative of e to the negative t first, using the chain rule, you'll have c2 times t e to the negative t. Then taking the derivative of t gives us negative c2 e to the negative t. Then minus c2 e to the negative t. Plus 25 e to the negative 5t. So I can combine like terms here if I want, but I think since it's not too terrible, I will just plug in my initial values now. So our first initial value, y of 0, is 5, will give us 5 being equal to c1 plus 0, that's nice, so I won't even write that, plus c3, actually I'm going to write it a little farther to give it a little space, plus c3, and then for the initial condition y prime of 0 being equal to negative 19, I will write here negative 19 being equal to negative c1. This will be 0, since the t is there, plus c2 minus 5c3. And lastly, we'll look at this initial condition and plug it into the second derivative, and that is going to give us 81 being equal to c1, that'll be 0 right here since the t is right there, minus, and here I'm going to combine the like terms. This is just going to be minus 1, so it'll be minus 2c2 And then, lastly, plus 25C3. And some of you may have already saw that I forgot to write the C3 here. I'll just write on the outside here. But definitely don't want to forget that. So now we have our system of equations. We just need to find what C1, C2, and C3 are. It kind of looks like if I add these two together, I'll get rid of the C1s. Similarly, if I add these two together, I'll get rid of the C1s, and I'll just have an equation with C2 and C3. So I'm going to do that. So let me rewrite these. 5 being equal to C1 plus C3. Second equation, negative 19 equals negative C1 plus C2 minus 5C3. Adding those up, the C1s cancel out. 5 minus 19 is negative 14, being equal to C2 minus 4C3. And then similarly, when I rewrite the second and third equation, negative 19 being equal to negative C1 plus C2 minus 5C3. 81 equals C1 minus 2C2 plus 25C3. Adding those up, the C1s cancel out. Negative 19 plus 81. Hopefully I can do math in my head. Is going to be 62 being equal to negative C2 plus 20C3. And then I could just put that under there, giving me 62 being equal to negative C2 plus 20C3. And that's wonderful because all I need to do now is add the equations up and the C2s cancel out, giving me negative 14 plus 62 is negative, or not negative, positive 48. Negative 4 plus 20, 16, so dividing both sides by 16 gives me C3 being equal to 3. Then, since I know what C3 is, I can plug that in to this equation here to get C2. So C2 is going to be equal to 20 times C3, which is 3, minus 62. And that is just 60 minus 62. So C2 is negative 2. Wonderful. And lastly, we want what C1 is. And we know C1 plus C3 is equal to 5, and C3 is 3. So C1 is just 5 minus 3, so C1 will be 2. And that pretty much finishes this off, other than writing the particular solution that satisfies the initial conditions, or initial values. And that is C1, so 2e to the negative t plus C2, which is minus 2 t e to the negative t plus C3, which is 3 e to the negative 5t, and voila, we are done. So much fun. Oh, shoot. Let's just kill that line. Okay, I won't box it in. And we are done.